I'm Hugo Bown-Anderson. I lead developer relations at Outerbounds. Although, if this job doesn't work out, I have an idea for an AI sofa store soon. And if there are any VCs in the room who want to chat about it, or even, hey, great. I knew I invited you for it. No, I'm kidding. But you're not here to listen to me or hear me talk about myself and my future plans that I've stolen from my current employer. You're here to listen and then chat with a bunch of really fascinating, interesting people working in the space. And what I'm going to do is give a brief introduction to each of them, and then maybe they can add a bit more color and talk about why they're interested in GenAI currently. So I'd like to start with Nikhila Ravi, who Nikhila is a research engineer at Meta, working on building foundation models for vision and language. Most recently, Nikhila co-led the Segment Anything project, a promptable segmentation system with zero-shot generalization to unfamiliar objects and images without the need for additional training. She's done a lot of other things, but maybe you can tell us a bit more about yourself and what you're excited about in the space at the moment.
Sure. So hi, everyone. I lead a research team at Meta. And most recently, we released Segment Anything. I think I spotted it on one of the slides. Yeah, cool. I also met someone else who's using it for their startup. So it's really cool to see the adoption since April, since we open sourced it with a commercial use license. So it's very cool to see all the companies built on top. I've been at Meta for 6 years. Worked on a number of different fundamental research problems in 3D computer vision, 2D computer vision, and most recently putting stuff in production, which is really cool. So Segment Anything is being used for a feature on Instagram called Backdrop. It was announced on Wednesday, and it's launching in November. So very excited to see it in an app that I actually use every day.
Amazing. To Nikhila's left, we have Goku Mohandas, who has spent his career developing ML applications across all scales and industries. Specifically, through a project called Made with ML, he's had the opportunity to help dozens of Fortune 500 companies and startups build out their ML platforms and launch high-impact ML applications on top of them. Goku has recently joined Anyscale as well. So maybe you can say a bit more about what you're up to now and what you're excited about, Goku.
Sure. Thanks, guys. My name's Goku, and yeah, I've been working in machine learning, backgrounds in biology. I've met a few other folks as well. Future work is to kind of combine the world of biology and machine learning, but I think it's already happening today. Joined Anyscale recently, and my job is actually probably very similar to what a lot of you are doing. Anyscale itself, we have expertise in distributed compute, and machine learning, even before generative AI, has been more and more about scale. So that's what that specialty is. But Anyscale, we've been kind of becoming the most performant and cost-effective way to serve open source LLMs. But my job is to layer on top of that, which is very similar to what a lot of you are doing, is to build applications and actually productionize them. So hopefully over the next couple of months and years, kind of continuously share our learnings on how to actually build and productionize these applications so that we can make things like the Sofa Company possible.
Super cool. Super cool, thank you. And I love that we've got several parts of the production story moving around here. Yeah, which brings me to Sarah Catanzaro, who is a general partner at Amplify. Sarah invests in the tools that we all wish we had earlier in our careers. Tools that enable data scientists and machine learners to collect, store, manage, analyze, and model data more effectively. Sarah identifies as a scientist first. Yeah, still, and an investor second, and still believes that her mission is to enable companies to become data-driven and to generate ROI through machine and statistical learning. In her words, and this is not even a paraphrase, Sarah is still that cuckoo kid who's ranting and raving about how data and AI will shift every tide. Tell us a bit more about yourself.
Yeah. So as you said, I'm a general partner at Amplify Partners. I focus primarily on investing in data and ML tools and platforms. I obviously have very good taste because I invested in said company listed up there. I do look at vertical applications of AI as well. It's funny in talking about generative AI and why, I focus on generative AI and data. Frankly, I've never done anything else. I've been investing in ML companies for about a decade now, but I have been a practitioner for a little bit longer than that. So I think that might also make me the oldest person on the panel, but yeah, c'est la vie.
Thanks, Sarah. And last but definitely not least, we have Shreya Shankar, who is a computer scientist doing her PhD in databases at UC Berkeley. She's taken the revolving door back to academia, which is something I really hope we get to. Because previously she was the first ML engineer at Viaduct, did research at Google Brain, and was a software engineer at Facebook. So let's not get to the question now of what took you back to academia. Maybe we'll get to that later, but what else would you like to add, and what are you really excited about in this space at the moment?
Yeah, so I research databases and human-computer interaction, and my thesis is on better experiences for machine learning engineers to deal with their data, and the HCI part is about making them happy. So I'm particularly excited about the monitoring and debugging, that phase of the production ML lifecycle. Happy to dive into that, and also the implications on generative AI.
Awesome. And in particular, I'm excited to get to a point where we can talk about kind of the differences we're all seeing in the space, what differentiates what's happening now from traditional ML. And I mean, a provocative question, hopefully we'll get to, is how relevant traditional ML will be and continue to be. But we are here today, as this gorgeous slide says, to talk about the past, present, and future of generative AI. And for those of you who know, you know. For those of you who don't, that's a data scientist or machine learning engineer up there in the tree, building models and collecting data and doing all these fun things and helping organic things grow by working with them. And he's barely aware of the platform engineer down on the ground beneath him, who's running all the infrastructure that powers everything he does, that has been nicely abstracted away for him by platforms such as Metaflow. But I'm not here for a sales pitch yet. So I'd like to start off by kind of thinking through what happens to traditional machine learning and deep learning tools in the space, in kind of the time we're entering into, and how they interact with generative AI and large language models and that stack. To that end, I actually asked the panel, I'm not trying to give my job away, but I asked the panelists to prepare questions for each other. And Goku had a particularly illuminating question for Shreya along these lines that I might get him to ask her.
Oh, yeah. So if you guys don't know, Shreya has published a lot, I think, over the last couple of years. That's how I actually found out about her a couple of years ago. And Shreya has thought very deeply about a lot of topics, and I'm actually glad that you went back to academia, because just because we see tools and products out there and certain approaches that companies and even groups of people take doesn't necessarily mean it's the right way to do things. So you taking a step back and looking at it from a more foundational level, I think, is a refreshing take people need. But I was just curious, and this could be in the whole scope of ML ops that we've traditionally been, applying it for supervised deep learning, but also maybe just monitoring specific, if you'd like. What do you think will stick, and what do you think will change when it comes to workloads like monitoring, or even tools and features of those tools?
Ooh. Okay, this was phrased slightly differently than what was emailed to me, so now I have to think of an answer
You
to
can go
the
for
new
whatever
question.
you'd like.
So I think LLMs feel very magical because they give you a prototype nearly instantaneously. When you were doing traditional ML before, it would take a few days to collect data. You would have to have some labels. You would iterate on it. You would encode your domain experts' ideas into numerical features. You would go through this cycle and then see some great performance and then be a little bit deflated when you push that to prod, and then the cycle kind of repeats until somebody says it's not meaningful, it's not giving lift to the business. But the cool thing about LLMs is that you can just do that. You can fail much, much faster. Your domain experts can actually go back and edit your prompts, for example. You can encode context in ways that are much easier than featureizing. So I think that like fast iteration that we can do now, where multiple people are in the room iterating on prompts, like that's super cool, and that will allow people to iterate quickly. Or it's recursive, I guess that's what I said. And then I don't know the second part of your question, but maybe that answered it.
No, I think it's a great foundation for it. For tools like maybe in the monitoring space, because a lot of your work that I've read has been kind of dissecting what is monitoring, what does it look like. I agree that it's fast to kind of fail and prototype. What do you think will be the pitfalls of that, especially around like something generative is difficult to evaluate, compared to something that is supervised and has
Totally.
labels?
So there's a lot of great research, maybe 5-6 years ago, around finding underperforming subgroups in your data, and how do we monitor that, and how do we do that in real time, especially when you're doing things like recommender systems. But a lot of that really relied on the fact that you could featureize your data, so you can have like strata in your data to monitor. Now when we're focused on unstructured data, like it's just blobs of text, or it's just images, and you don't have that kind of metadata around it to figure out what does a subgroup even mean in your data? How do you identify those? How do you reliably track them? How do you know what's underperforming? I don't know if anybody knows how to solve these questions in at least this unstructured data world. But that's just one thing, I'm sure of many.
Yeah. I think something cool that we are seeing is the incumbents that were doing, let's say, workloads like testing or monitoring for supervised deep learning have not completely pivoted, but have been able to extend their work for the generative use case. And then we also see a whole new genre of companies like Langsmith, for example, that are recent, but are now like same workloads for this workload that everyone has been thinking about. So I think it'll be interesting to see how it all plays out.
Absolutely. I do really wonder what the role of traditional ML and traditional data will play as we kind of move into more foundation models. So, I mean, a provocative question is, will we need XGBoost and logistic regression and these types of things when we enter this space of more use of LLMs, foundation models?
I think like the fact of the matter is that over the past couple of years, organizations have spent significant resources modeling, testing, really curating their tabular and time series data. And they've done so because they've identified ML use cases that really drive value for their business. So arguably, like a company like Stripe could not deliver upon their value prop of payments and 10 lines of code without really accurate fraud detection models and things like that. I've actually been surprised by the number of companies that I've talked to, like in the past 1 to 2 months, that are rebuilding their feature stores or iterating on their kind of classical ML training infrastructure and things like that. So frankly, like I don't think XGBoost is going anywhere real fast because those tabular and time series data use cases remain so fundamental and so mission critical to so many companies. It's possible that foundation models will at some point become performant enough on these data sets that they could displace those other models. But those things work too, and I think that's something we need to constantly remind ourselves. Like you hear about, the rat race between OpenAI and Anthropic, et cetera. But like when you're at a startup or a kind of fast-growing tech company, you care more about like good enough, not necessarily the best, and like good enough that doesn't break. The old adage of like if it ain't broke, don't fix it is something I see all the time in tech.
Absolutely. So in that case, before we move to production workloads, what in the dev stack changes? And maybe Nikhila, you can tell me what you think about this. When you're just, exploring data and maybe, I mean, one example is using LLMs to think about feature engineering and that type of stuff. But before moving to production, what can change in that stack with the advent of foundation models?
Yeah, absolutely. So one of the things that I primarily work in the research space. I don't really work in production. We sort of hand over models to production teams and they productionize them. But on the research side, we found that actually you can use models to annotate the data yourself. So instead of having humans go and annotate data, we can use either models in the loop. So for example, for segmentation, if you wanted to manually draw a boundary around an object, that might take up to like 3 minutes for the complicated object. But with Segment Anything, you can do it in around 14 seconds. And so it significantly speeds up annotation, and not just interactive annotation, but you can automatically also annotate data. And if you actually look at the statistics of generated data sets, so one of the things that you do in annotation is you can have multiple people annotate the same thing, and then you look at the sort of inter-annotator consistency, which is you take the IOU of two segmentation masks and you see what the overlap is. Now, if you take a model and you annotate the same thing and you look at the overlap, it's almost as good as a human. So once you get to that point, you sort of eliminate the need for humans to annotate things. And I think we're moving more to a paradigm where foundation models are doing a lot of the annotation, humans are just verifying the correctness, and then we can reach sort of data scale that we need to train these models that have like, train these like billion scale models.
Awesome. Goku.
I just wanted to add a point to Sarah's point. Supervised deep learning is not gone. In fact, it's like powering, it's increasing, right? In terms of the number of applications that companies are working on, and what's, I would argue, revenue generating as well, compared to maybe a lot of the LLM applications that we're seeing. But another trend that we're seeing, like I'm personally working on that I'm seeing a lot, is kind of the combination of the two as well, especially when you have a certain SLA that if something is going to be powered with a generative model and the user is not expected to wait more than 5 seconds, that's one LLM call right now. And maybe in the future we'll have more in that time frame. But the other pieces in there, you may heavily depend on supervised models to maybe route what the query is to a certain subset of LLMs and things like that. So I think it's continuing to increase, like you said, and we're starting to see like a merge of supervised and generative come together.
I actually have a question for the other panelists too, related to like how the dev stack is changing. One of the things that I've been thinking about is that like in traditional software development, like you release a new feature, and maybe you A/B test it. Maybe you do something like a canary deployment, but like once it's released, it's kind of done. You move on to the next thing. And I think with a lot of LLM-driven features, we may release them, but then what I'm observing is that people start iterating on the next version of that feature. So they start iterating on the model again. And so we talk about rapid iteration in the context of software development, but usually it means like we build things fast, we build new things fast, not we rebuild the thing that we just shipped. Mm-hmm. And I've been wondering, like, as we start, focusing more and more on releasing LLM-driven features and then iterating on those, re-implementing those, like, what will change? Like, do we need better monitoring? Do we need different monitoring? Do we need different analytics? Do we need, systems like that which you just described, where perhaps we have two models and we can route the query to the right model? It seems like this difference is subtle, but could have a profound impact on like how we build.
No. I mean, I can quickly just chime in on one of the aspects. So I think evaluation would be key. And I think this is like probably one of the most nascent things when it comes to generative models. Everyone has their own way of doing evaluation, but like some broad themes that we're seeing are, this is like one big generative application. Try to break it up as much as you can. So something that is maybe less generative and slightly more deterministic would be like the retrieval aspect itself. So you have an embedded query, you pass it to your vector database, you receive the top K. Can you create a data set with like your golden set of source or sources and just do like a simple recall there? So get a score there. And then on the actual generative side, I don't know if it's the right direction, but the trend has been use a larger model, a judge of sorts like GPT-4, to try to score the response and give you reasoning for why. Pseudo hand-wavy vibe check wise, but we do see a lot of teams trying to kind of use retrieval score, generative score, combine them together to come up with a quality score, so that when you do change something, whether it's chunking logic or your embedding model, whatever it is, you can start to quantifiably compare across, which I think is really important because even on Hugging Face's leaderboard for embedding models, if you just blindly take what's number one, empirically that may or may not work out for you. Empirically, it hasn't worked out for us. It's in fact like something like number 10 or 9 for us. So just being able to test out these different things is really key. But I'm sure other aspects are also super important.
Well, I know that Shreya's been thinking a lot about debugging deployed LLM chains and how that differs from traditional ML. So maybe you can even tell us the types of questions you're thinking about there.
Yeah. So one thing is that we have a study going on. At least a year ago, we released like a paper on ML ops, and we're kind of doing a similar one for LLMs. But the stages in the ML development cycle are the same. Like there is data collection, processing on a schedule. There is experimentation, and that is like a thing that people do and they continue to do, as Sarah is saying. There's a multi-stage evaluation deployment in traditional ML that is also there for LLMs. You don't just like deploy and like sit back and be happy. You deploy to a small fraction of users, or you deploy a V1. You iterate on it. You evaluate. You deploy it to more users like that. You keep going until you like are confident that you can sit back for a little bit at least. And all of that is the same. It's just that the iteration time is now faster in each. Maybe not data collection and processing. That's like that one's really hard. But I think all of the other stages are pretty much the same. So now the question becomes like, how do you really enable anyone, any stakeholder to go back and improve your system? How do you build systems and interfaces that show your prompts to people? In one of the interviews that we're doing for this interview study, there's a prompts.py file that someone sent to their BI people and was like, hey, is this good? Like, does this help you answer? Is this kind of the questions that you would ask? Basically, if I'm trying to automate your job away. And so like having this like such tight collaboration that I feel like you would never really share your code with your end users before. That part, I think that makes debug, and I'll answer your question about debugging. I think that makes debugging a little bit different because now you can catch potential bugs a little bit earlier. I think the stakeholders are also very invested in where things fail. Like someone described evaluation for LLMs as a vibe checks. Like people are looking at responses, trying to see if there's a vibe. What I find particularly interesting is in traditional ML, we monitor average metrics, and that's what we use to determine performance. But these days, when people are looking at LLM responses, they're kind of adversarially testing it in the beginning. Or they want to see like the worst case performance before they can establish some sort of certainty or confidence. So it doesn't matter if your LLM has like, 70% accuracy averaged over 100 queries. Like what matters is in those first 5 queries, the user really likes it. And so that's a completely different thing to monitor, like from the monitoring perspective. And I'm like thinking about how do I build tools for this. As a side note, I am kind of co-founding, working with a consumer AI company. And this is like the question every day. Like, how do you look at your users' behavior and understand how they perceive the AI? And then that determines what you want to monitor. And I think that's just such a hard problem. I don't even know how to answer that. We're so early stage.
Definitely. And I want to drill down a bit more into what changes in the prod stack. But to prepare for that, Nikhila actually had a wonderful question for Goku about challenges in classical production ML that maybe you could ask and we can hear from the lion's mouth.
Yeah, sure. So as I said, I work in research. I don't really know that much about Fortune 500 companies and what their ML use cases are, but you have worked with lots of big companies on productionizing ML and delivering value. So is there a specific use case that really highlights the challenges of going from research to production? So some of the challenges I think you mentioned around scale, integration. Would love to get a use case to like really highlight that.
Yeah, I'll try to talk about, I guess, really quickly about the supervised space and then maybe what continued into the GenAI space as well. A lot of it is actually topics that Ville covered in the slides already, but with supervised deep learning, depending on the industry and use case you're in, you probably don't have to think about too much scale. And again, this may depend on your data modality, right? If you're dealing with videos from the get-go, maybe scale is something you have to think about. Even a little tinkering research project you can't do in your local laptop. But traditionally you can. And if things go right and you're actually building a product that people use, either or a combination of the data processing, training or tuning, or the serving of your models, one of those or a combination will scale out, right? And that's a good thing. But the issue, and by the way, a team like Instacart, right? Their data needs may actually be small if you're separating it. They actually have smaller models, so their training isn't actually scaling out either, but the serving piece is because you have multiple models, even granularities beyond even zip code, right? So that's like an example of something that can quickly grow out of control, even though you're not training massive models on massive data sets. So in these scenarios, it's Pythonic in day one. You deploy it, you have some iterations, you have one of these things or a combination has grown, and now you have to bring in a team that knows something like Scala or even worse, like C, to help scale out some of these workloads. That's not a problem, but in and of itself, but it is a problem when the people that developed the research and that developed these models are now like handing off something, and there's this disconnect between the original logic and what people are developing now, and then any kind of iteration, that handoff is another like added friction point. So scale was and is a big problem, scaling out workloads. And with GenAI, I feel maybe scale is even more present. Maybe it's a day one problem, maybe, in the sense that, yeah, you could tinker on a project if you're building a RAG application locally, but if you switch that on and connect it to like production data sources, being able to run experiments, load, chunk, embed, index at scale, that you're gonna have to think about that. And then even if that's offline and you're in a context like ByteDance, for example, where new data is always coming in, even though the way you index doesn't change, but you need to represent that new incoming data and actually get that into your vector database to use as part of your application. Scale is another issue there. So scale is like a very large issue. And the other one, certainly like dev to prod, Ville touched on this as well. I'll keep this short. In general, the closer you can make your dev environment closer to prod, the better it is. And the big themes are compute, like what you're actually driving on, the environment itself, beyond just like your Python environment, but your system dependencies, your CUDA dependencies. The closer you can get that to what will actually be in prod, the better. But something that's hairy and is not figured out is actually connecting to your data source. Maybe in dev, you're on a static file, but in prod, you're not. You're going to be connected to a very dynamic resource. So these are all problems that I always faced, regardless if it was a Fortune 500 or a Fortune 100 company with a new data science team or like a new startup. But I reached out and said, okay, the startups that are doing well, like Netflix and Instacart and Spotify, how are they solving this? And that's one of the reasons I ended up joining Anyscale for open source Ray, was solving a lot of these issues. So instead of building another startup, I decided to join someone that's been doing it for a while.
Very cool. Yeah, I think one funny anecdote is for example, I was mentioning the segment anything is being integrated in Instagram for this feature. So for research, we wanted to build the most general model that would work on all image domains. But Instagram, most people really care about people and dogs. And so having a very general model isn't very useful. And so there's obviously often a conflict between the research goals and the production goals. And they don't need a VITH backbone. Maybe dogs and people, you can get sufficient accuracy with a VIT small. So there's a lot of handover that product teams have to deal with.
So Sarah, I know you have a lot of thoughts on what is changing in the production stack with respect to generative AI. So perhaps you could say a few words.
Yeah, I mean, certainly I think when I think about like the production stack, it seems like there are almost 2 LLM stacks that we need to discuss today. And I know we plan to talk a little bit more about open source models, but if you are using the LLM APIs today, the commercial LLM APIs today, frankly, like the software feature development process, it doesn't look that different from traditional software development. I think most of the challenges that people face when they're working with the GPT-4 APIs to build new features they relate to the same set of problems that developers face when they are shipping a new filter or shipping a new interface. There are challenges associated with working with complex monolithic code bases, challenges associated with connecting to disparate systems. Now, if in comparison, what you're doing is fine-tuning or pre-training an open source model, the set of challenges you face is completely different. And now you need to think again about data collection, data curation, how to wrangle compute resources, how to scale up. Then I think, in fact, the set of challenges you face looks much more like the set of challenges that we faced when working with the classical ML stack, which Shreya kind of alluded to. It's interesting because I fundamentally believe that both are going to need to coexist. And I do think that a lot of challenges that companies are facing or will face as they adopt open source models can be addressed by extending existing ML tools and platforms, tools and platforms like Metaflow and Outerbounds. But if what you're doing is just writing an API call, then you probably don't need a feature store. Perhaps you don't need a data science framework, or maybe you do, but for a different set of use cases.
So something we've been kind of circling around is how we work with data. And data still seems fundamental to all of these questions, if not perhaps increasingly so. And Sarah actually has a really interesting question for Nikhila around data. So maybe you could ask that.
Yeah, absolutely. So in reading the Segment Anything paper, I think one of the things that really stood out to me was that you developed this new data engine, which seemed really fundamental to the state-of-the-art performance of the model. One of the things that I've been thinking about is how will data collection, data curation, how will the way in which we work with data change as we embrace foundation models? So I'm very curious to hear about your experiences building that data engine.
Yeah, sure. So just for some context, segmentation data doesn't exist naturally on the internet. So compared to something like training a language model, you can just scrape the internet, use the language directly. For segmentation, you need actually to get annotations on images. And so to be able to collect that data at the scale that we needed, we actually had to create this human-in-the-loop data engine. And what was interesting is that we actually used the Segment Anything model as part of the data collection process. So annotators would use the model, would click on various objects in an image. We would annotate, we would get those segmentation masks. We would then train the model would get better, use the model to then collect more data. And we did many iterations of this data model refinement loop. And at the end, the final data set was 11 million images, 1.1 billion segmentation masks, which was automatically annotated with the model. So in the end, we didn't use human annotation at all. So the idea of the annotation was to get a model that was good enough to annotate data. And I think, as I mentioned previously, I really think we're moving to a phase where models do a lot of the annotations, humans verify accuracy, maybe make some refinement, but I don't think there's going to be that much human manual annotation as we've had previously.
Shreya, you can weigh in on this, because one thing I do appreciate about your work is that it's deeply technical, but you almost provide a sociology of how people in the space, data scientists and machine learning engineers, work as well. So how do you see changing the way we work with data with the advent of generative AI?
Oh my gosh. Where do I start? So I'm actually super curious. Raise your hand if you work at a company that started this year or started a company this year and are using Spark or Hadoop for data processing. Small number of hands, or maybe people are not raising their hands.
Some people went to raise their hand and then lowered it very quickly.
No, nothing bad about
over there.
Spark. Yeah, I'm just so curious. So I think that we live in a really interesting age where compute has changed so much over the last just few years to where you can do things in your browser, you can run things on the cloud, you're distributing all sorts of computation everywhere. And it makes for extremely complicated data pipelines. I can give you examples of things that I've seen, things that I've worked on, but when it comes to generative AI, I think people are still trying to collect clean data, good data, like that part hasn't changed. But where we're running these jobs and how we're coordinating all of this and syncing all of this and making sure the quality is good, I think that's changing. Like we used to run all sorts of ETL jobs like 5-8 years ago that I don't know how we're running now. I think they're running on an individual basis. They're running in the browser. They're being cached. They're being like it's all different. And I think also with generative AI, the fact that we call models that run on other machines and we call them from the browser, that also changes the way that we do data processing. So I don't know how it will change in the future. It's a really exciting time. I think this is the thing that's most exciting to me is just the merging and the blending of all the compute and data paradigms, like the merging of the data engineer persona with the data scientist persona. Like now data scientists are querying like terabytes of data in their Jupyter notebook on their computer. Like I think that's a crazy, crazy thing. And I'm super excited to see how that changes with even more like generative AI.
So what are thoughts on how the roles will change more generally? Will data scientists still be a thing or machine learning engineers in 5 years?
I think everyone is going to be a data scientist in the next 5 years. That's my thought.
Awesome. Let's give a round of applause for that prediction, which we're going to meet here in 5 years and see what the heck is going on.
Everyone will be a web developer and everyone will be a data scientist. Like think about I don't know if you use ChatGPT, but like at least personally, like my productivity in so many verticals that I was kind of competent at is now like shot off the roof. Like I could probably build an iOS app and I haven't really before. I can definitely build a website. I can architect data pipelines. So I imagine everyone can, like, even if you're not like fully trained in it.
Absolutely, it's magical.
Yeah.
So something Sarah gave voice to earlier. We live in a space where, at a time where some models came out, ChatGPT released that seemed to capture global attention in a lot of respects. Then open source models started being released, and we're all playing around with all these different things. Goku and I were chatting last night about they have a wonderful interface UX on their website at Anyscale where you can query the RAID documentation. And can I say what you told me last night?
Yeah.
Okay, cool. Just wanted to make sure.
The research, right? The work-related stuff. Yeah.
That some queries will be piped to GPT-4 while others will be piped to a fine-tuned version of Llama 2, right? So it's a fascinating time to be working with all of these different models. I just wasn't sure if that was under FriendDA or not. So, but I mean that raises the question for people who want to work in this space and getting into it. What do we think about this? Vendor APIs versus fine-tuned open source models, and where this space will be going.
So I can share some observations from speaking with various teams. I think right now, the majority of ML, LLM teams, those that are implementing LLM-driven features, are working with commercial LLM APIs. They're working with, Anthropic or OpenAI APIs or Cohere, something like that. There is a small number of companies that have developed their own custom models, perhaps pre-trained those models. There's a smaller number of companies that have either fine-tuned or done additional pre-training with open source models. In fact, my ears perked up. I was like, wow, you might be the first person I've met who has actually deployed fine-tuned Llama 2 in a production environment. So right now, it seems like the commercial LLM APIs are dominating the market. But when I talk to these various ML practitioners, most say that they do plan to adopt open source models or custom models for at least a subset of use cases. And their rationale for doing so is quite sound. Usually there are concerns around having tighter control over their product roadmap. I think Ville kind of alluded to that in talking about this theoretical example of the couch store, sofa store.
It might not be theoretical for a long time as well.
We'll talk after the others have concerns about data security, or perhaps their customers have concerns about data security. And so their motivations for adopting open source models are real. But then when you ask the question about what is your plan to transition from the GPT-4 API to fine-tuning Llama 2, you get blank stares. People don't know what open source model they should adopt. They don't know how to think about finding the right data set upon which to fine tune. They don't know if it's legal to use their cached input-output pairs from working with OpenAI's APIs to actually fine tune a model. So it still seems like there's a major leap from just prompting open source models to actually fine tuning or training open source ones.
I think adding on to that, ownership is a big piece. I would say that's the first perk of kind of migrating from proprietary to open source. For us, actually, there's so many different directions to take this, so maybe I'll do one at a time. My personal hope is that if the quality of GPT-4 is here, and let's say 5, 6, 7 keeps going up, my hope is that open source models like Llama Family, and we have so many others coming up, is that quality also continues to catch up. And for things that we use GPT-4 today, and we say this is perfect, we can't use anything else, hopefully open source does catch up there, but even without fine-tuning, but certainly with fine-tuning. And I think it starts to become use case by use case. So today, if I use GPT-4 to generate the perfect response for an email, next year or in 6 months, I hope to use an open source model to do that, and that's probably good enough for a long time. But maybe if it's something, I was talking to someone about protein folding, there are different foundation models for that, but let's say for some reason you're using GPT-4 for that, you should probably continue to use whatever is proprietary and keeps going up, right? You always need the continued quality and emergent kind of properties there. So that's one thing. And yeah, I think having open source models, we internally publish a lot of studies is fine-tuning even worth it? If you're trying to, not for fact injection, but for form to look a certain way, like SQL generation, we proved out fine-tuning Llama 7b beats GPT-4 out of the water, right? We have code and studies on this as well. So I'm sure we're going to start seeing similar niche applications like this, where smaller fine-tuned open source models and even just more contextual applications like RAG apps outperform these more expensive proprietary solutions. And at the end of the day, the goal for us as a company or for your users, they don't care whether you use open source or proprietary. We want to serve the most performant and most cost-effective thing. So whatever makes that work. So even for us, that's why we still route a small subset, but high complex queries to GPT-4. And we may always continue to do that for future versions as well, but our goal is to try to make as much of the traffic go to the best appropriate model that we can. And if that means we can leverage tuned open source models to do that, then that's great for us because we can serve the best app at a cost-effective way.
Yeah, I think embedded in there were also some very interesting thoughts around universal versus domain-specific models. So I'm interested in all of you, how you see this playing out.
So today, I think when we typically think about developing new features, we typically think about adding new capabilities, solving specific problems for our users. It's very much ingrained in kind of the product development process. It's very much ingrained in the software development process. We don't think about developing solutions that generalize to a wide range of problems. We think about what is the problem that I can solve today, or what is the problem that I can solve over the next 2 months that will increase user retention, that will support lead generation or something like that. So frankly, I think today, what you described in the context of Instagram, needing to use the segment anything model to support users who are taking photos of people or dogs, like that is actually very true kind of across the board in industry, which does lend itself to a world in which most companies are fine-tuning LLMs and or just using models for task-specific purposes. But I think we're starting to learn how to think differently about the software development process. We're starting to learn to experiment in ways that enable us to reimagine what software looks like. One of my portfolio companies is called Runway ML. I'm not sure if people in the audience have played with their video editing tools. But I remember a debate with Chris when they decided to abandon their video editor. So, most video editing software, it had, Adobe, et cetera, they have dozens of primitives that you can use for, again, specific tasks, maybe background removal or automated rotoscoping or grayscaling and so on and so forth. And, Chris said to me, like, we can compete feature by feature. We can take each of those primitives and develop new models that will map to those capabilities, or we can develop a bunch of powerful models, see how people use those models, and then completely reimagine what a video editor should look like. But we need to be comfortable with the phase where, our product doesn't really look like software. It doesn't really look like an application. And I think many more companies will have to go through that transition before we see true use cases for generalization, general purpose models.
Another interesting point from that is that, and also building off of what Goku said, is having LLMs route to different models. So, for example, there's many off-the-shelf computer vision models, depth prediction, object detection, 3D reconstruction, which you don't really need to develop from scratch, but actually having an LLM interface that will then delegate to the appropriate model, maybe similar to the different models that are available on Runway as like a different paradigm to having like a very general purpose model or very task specific models.
This is kind of near to me. I feel like there's two themes. So there's companies like Harvey, Character, Glean, for example, that all leverage GPT-4, but this current class of LLMs that we're all familiar with, where it's ingestion of English or like human written text. So that's like one class where they don't have to train their own foundational models from scratch. And I think the majority, at least for now, will fall in that category. I see the second category, which I thought would be 3 or 5 years from now, but it happened 2 months ago, is when you have a context that doesn't fit in this English paradigm, and there's enough data to do training from scratch, we see industries adopting. So the one that I was talking about earlier, and it's actually almost a perfect analogy. You have like to train these LLMs from scratch, next token or mass token is the way you do pre-training. So in biology, you have sequences of nucleotide sequences where you can do the same principle and have a foundational model from scratch. And there's companies now doing this. Actually, the team from Facebook that was recently started a startup in the space and are working on it. So I think that's amazing. I'm not sure if this will be proprietary or open source, but I think it's really great to see foundational models on a completely different contexts coming out for these industries. But I still think the vast majority will be in this former category. They'll build on top of LLMs that we're familiar with today.
Great. I appreciate all of those insightful thoughts a lot. I do want to leave some time for questions from the audience. I do have a couple of more things I want to get to first, though. I have one question which isn't even a sentence. All I wrote was multimodality ? So multimodality? Nikhila, maybe you can tell us about, with respect to the work you do, what type of roles you think multimodal models can play in the coming months and years.
Yeah, sure. So I'm sure many of you now have access to GPT-4 Vision. If you're a pro user, I had some fun playing around with that today. But I think what's interesting is that these LLMs actually have a lot of world knowledge, which is also includes understanding visual world. So there's a couple of interesting papers which were sort of asking an LLM to give the instructions on how to open a microwave, and it can actually provide you the instructions to do it even without seeing a picture. So, LLMs have a lot of world knowledge. If we can combine it with visual knowledge as well, like if we can give the LLM eyes, what could it do that it can't do currently? And so I think we're definitely moving to a paradigm where all LLMs are going to be inherently multimodal. And I think I'm really curious to see what use cases emerge from that, because I think until ChatGPT came out, we couldn't really imagine the scope of possibilities for what the kind of model could enable. And I think so far we've only seen glimpses of what a multimodal model is capable of, but now we're seeing more and more use cases. Personally, I've found it useful for solving crosswords, so I'll be using that moving forward, but I'm sure there's many more really exciting use cases, and I'm excited to see what they are.
I think maybe we should go down, because I think this is a big topic. I guess like two thoughts for me. One is pertaining to the second one, but the first one, when I saw the demo like that OpenAI did with the bicycle thing, first thought was like, I'm not going to be sitting there taking a picture of these things. So for me, I think multimodal is great, and I think it's going to be the future. I think a third missing piece would be the medium in which we inject data into this service. So I saw Meta had like this class thing, and first of all, it was really cool. It was like the interview one, but something like that makes a lot of sense where I need the data input to be as frictionless as possible. Text with ChatGPT is great. I'm sitting there, I'm developing, I'm putting in my code, and I get an output. But if I can just have, look at that glass there and get information about it, I don't think I'd sit there taking a picture, even if it's like a powerful thing, unless it's like a very specific thing. That's one thing. And the second thought is maybe a question for you as well. With open source models like the Llama ecosystem, I feel we were able to close the gap with proprietary models. It's still not trivial, but it's because it's all in the text realm. Do you think the gap will, actually, I initially thought the gap will widen when we go multimodal, because it's a lot more complicated to get quality image and video data. But after seeing like the work that you're doing, maybe not, right? Maybe we'll continue to also close the gap when in the multimodal space as well. But yeah, just curious about your thoughts on that, and then I want to hear other people's thoughts on.
Yeah, so I mean, we're only in the past couple of days evaluating the quality of the current model. So we only really got a preview of cherry-picked examples of GPT for visual. So we're still like figuring out what is the state of the capabilities. So, and I think in terms of image data, there is a lot of image data, and for this particular type of use case, you don't need segmentation masks. Image text pairs are probably sufficient. So I think from that perspective, I don't think the gap is as big as it was to get a huge segmentation data set, which took us like a year to build. So yeah, I don't have a good answer for you yet, but maybe soon we'll have a good understanding of what the current state of the art is. So.
Multimodality, Sarah?
Multimodality. I think one of the most important responses we can give to like any question posed to us today is just, I don't know.
Yeah.
You alluded to this. I remember having conversations with folks when like GPT-2 and then even subsequently GPT-3 were released about like how we might use language models. And oftentimes, people would just say like, I don't know, I don't think I really have a use case for language models. We don't have that much unstructured data. We primarily work with time series data. And then ChatGPT came out. And it, sparked people's creativity. And I think we're still just at the beginning of exploring how language models can enable us to build completely different products. Like I think ultimately the types of products that we build with language models will look very different from what we see today, and very different from the applications that we've interfaced with over the past decade. I was initially kind of skeptical about multimodal models. I'm like, how many use cases are actually multimodal? How many business problems today can be solved through better performing multimodal models. But I think the fact of the matter is, like, some like creative human being will figure it out. I think perhaps like the most undervalued skill that we need to continue to cultivate today is just creativity and experimentation, because we're no longer just emulating the things that exist today. We need to think like, okay, now that these new technologies are possible, now that we can do things that we could never do before, what are all of the things that we can build that just have not been built? So I don't know.
And building off of that, we were talking earlier this week about how ChatGPT is just a UX around a model that existed, but that was so critical to spark people's imagination. And chat is a very natural interaction mode for people because we use text-based applications every day. But for computer vision systems, so for example, for Segment Anything, we actually spent 8 months building a really high-quality demo because the interaction mode is so different from what anyone has ever done before. And in order for people to really understand the power and potential of this model, it was super critical that they could try it really easily. And so I think, what is the form factor that is going to make multimodality capture people's imagination, think of these use cases that they couldn't think of before?
One more thing to add to that, we had John Schulman over last week. He's the co-founder of OpenAI, and he shared in the beginning when it was like an internal pilot testing kind of scenario, it actually there wasn't much traction. And I think they may have had the chat interface, maybe not as polished as it is now, but he alluded to the fact that when they actually made it public, all these network effects started to take place. People would share like, hey, I just tried this prompt, that prompt, and that. So I'm sure a very similar thing will happen when multimodal goes more widespread. But yeah, I think it'd be really interesting to see.
So Shreya, multimodality?
I have nothing to add.
Incredible.
Very cool.
I love that Nikhila kind of spoke to the importance of UX and design. And I do think that's something I would have liked to get to this evening, but we may need to get the band back together at some point because there's a lot more to talk about. Sarah mentioned that, a lot of these questions, the best answer is I don't know. So in the spirit of that, I'm going to ask a question which that will definitively be the best answer to. But as we kind of enter chapter 2 of the generative AI space race, if you will, I'm wondering what you all think it will look like. We all work generally in machine learning, so I think it's okay to make predictions with error bars. But I suppose my question is, in 2024, what do you think will stay, and what do you think will change? So maybe we can start at the other end this time, and then move down, so that Shreya doesn't have nothing to add. Oh, just kidding.
Yeah. I really like what Nikhila said earlier about the UX engineering of it. I think right now people are really learning, building intuition for when to push the model performance versus when to fix things or push performance with better UX, where performance in some way is customer happiness. So I really think that that's one thing. Another thing is we just have a lot of data and our compute powers are growing, and there's just going to be bigger models and more people are going to put out bigger models. And I don't think anyone can really predict that ChatGPT really took everybody by storm. I don't think people know what something like GPT-5 could do. I think it'll just be super cool to watch.
So very practically speaking, I do think we will see increased adoption of open source models. I mentioned before that I think like a lot of companies are bottlenecked as they think about transitioning from commercial APIs to open source models. But I do believe that even if open source models don't catch up with commercial models, their performance is actually currently good enough such that they can be justified for many business use cases, whether there are concerns around data security, latency, so on and so forth. I'd also agree that I think like there is so much room for UX experimentation, and I think we'll see more of that in 2024. One of my frustrations as an investor today is that so many instantiations of applied AI, they really just look like different flavors of ChatGPT. When I think about the ways in which companies like OpenTable or Rent the Runway have implemented LLMs, like it really just kind of looks like ChatGPT. But I think, as we get more comfortable with using these models, we'll start thinking beyond these kind of chatbot interfaces. How could people interact with LLMs? How do we integrate it more deeply into the product so it's not just, some chat sidebar? Those are my predictions, plus I don't know.
I think that in general, open source models are going to be faster, cheaper, and better. And I think this year has been defined by optimizations when it comes to fine-tuning and serving optimizations that are open source. But I think going forward, we'll see optimizations that are maybe a bit more proprietary, or even if they do become open source, a smaller subset of people will be able to act on them. So we have companies like Anyscale, Outerbounds, Together, Fireworks, where the optimizations start becoming not around quantization and things like that, but being able to do things across heterogeneous resources and setups like that. So I think that's a general trend. But the reason why it's important to have faster, better, cheaper is when we're building an application, to hit a certain SLA, don't make the user wait more than a certain amount of time. Right now, we can afford to use one generative model, maybe the last one that generates a response given all the context. But we personally use like supervised models as nodes in that application to do the routing, to do the re-ranking. And we do that because we can't use LLMs to do those even smaller ones that we could fine tune. But if things are cheaper and faster, then we can, which means in the same one call and being able to respect the SLA, using more LLMs to do more of the jobs, which is favorable because I don't want to actually constrict to just 4 classes in this node and 5 classes there. I want to leave it open and open-ended and be able to more organically come up with the response.
Cool. I'll try to think of something different. I guess I have 2 things that I think are quite interesting. One is, I'd say like the rise of the small models. So recently, I think there's been several models in the sort of 7 to 8 billion parameter range. So there's like Llama 2 has a 7 billion model. Adapt came out with a 8 billion parameter model. And then I saw Mistral had a similar like 7.3 billion parameter model. And what was really interesting is that they're sort of outperforming some of these bigger models now, bigger, older models. And you can fine tune them on a single GPU. You can run them on a MacBook. Maybe you can run them on a mobile device. And if we can get these small models working as effectively as some of these bigger ones, fine tuned for specific use cases, maybe more personal, what kind of use cases might that enable? And the second thing, which I've recently been looking into, is sort of alternative to GPUs. So yesterday I met the founders of this company called Etched, and they're sort of etching the transformers into silicon and making very custom chips specifically for transformer architectures, and trying to see how that might improve cost and reduce cost and improve inference speed. And what new use cases might that enable? So I think those are my 2 areas of interest.
Fantastic. Well, thank you all for your future music predictions there. And now we're going to take some questions from the audience. So my main man, Eddie, is going to run around with a microphone. You'll need a second one. Or maybe while we're waiting, okay. Great. So we've got a question over here. So we're going to have questions for 10 or so minutes, and I appreciate that we've been talking for a while, but we just couldn't stop with all the excitement going on. But then there'll be continued revelry and drinks and food and swag, all of these nice things. So, and let's try to keep it to questions as well. Or cut you off after 45 seconds of babbling, if that occurs. Not that, I don't even know you, sorry. You look lovely.
Well, we're connected on LinkedIn. I'm surprised you don't know me. But okay, amazing panel. Really loved all the insights. Nikhila, Goku, and Shreya had amazing insights. My question is for Sarah. So in the world of foundational models where you have extremely high cost of training these models, but the one model which really stands out is the runway model, where they end up training their own models, and it fits right in the piece with their SaaS distribution. So if tomorrow Nikhila or Goku had to start a company, Shreya has already started one, what advice would you give them if they should train their own models, and how close they should be to commercialization? Because it seems like a zero-sum game right now where you're burning hundreds of millions of dollars training the model, and you're not even like making any money.
I think everything really hinges upon the use case. There are certain use cases that can be addressed today with commercial LLM APIs, and certain companies where their source of competitive differentiation will not, in fact, be the model or model quality. So if you can enable the user behaviors and workflows that you want to enable with commercial APIs, and you don't see ML as being critical to your competitive differentiation, then like don't spend time, energy, heartache, and of course capital on pre-training your own models from scratch. I think for the set of capabilities that Runway wanted to be able to support, those weren't possible with any commercial or open source models that were available at the time. Now, interestingly, I think by building those models into great product experiences, they've been able to create a company where revenue grows faster than spend, which makes it venture backable. But that's not going to be the case for everyone.
So I kind of going back to what you said about a zero-sum game. And, there's players in this environment that have a lot to lose, and Google in particular, right? Where you have a $300 billion ad industry that they have everything to lose right now. So, where does, and I'm not like a technical expert in this, more so just looking at it from a business perspective, what does the little guy have against, for example, Google Cloud's Vertex AI? I mean, so when there's the supremacy of cloud infrastructure that exists within these big tech companies, how can, open source imaginably catch up to such an unimaginable, monopolized competitor like Google, or OpenAI that has the backing of Microsoft? I mean, how do we prevent these companies from taking over the world because they now control everything? They control the infrastructure, and now they control the intelligence.
I wish there was a better answer that I could give you to that, or that I could give to that question. It's a question that I feel like I get all the time. Like, how is this startup, how is this company, how is this project going to compete with Google, Meta, AWS, and so on and so forth? I don't know, but they do. Look at Snowflake. Snowflake is built on AWS's infrastructure. They built a data warehouse. AWS also built a data warehouse, and yet Snowflake controls more market share than Redshift. Look at MongoDB, which is one of the most successful companies building OLTP databases. I often like to look at the database field and think about analogies in the ML space. I don't know how it happens, but David often beats Goliath. I think oftentimes these small, nimble teams, they can just out-execute kind of these more bureaucratic and convoluted organizations. But there are plenty of examples in the past that show that it happens, and so I believe it'll continue. But not sure if others.
You nailed it. I think it's priorities too. Yeah. For someone like Google, let's say you're competing in something that's not one of their top 10 priorities, they're likely to watch, and it could be a great outcome for you, right? Maybe your company gets acquired, whatever it is. They may also try to compete, and you may be squashed. But what this whole GenAI space has enabled is that companies that are the Davids are able to impact their number one priority, search ads, right? So I think just within search, companies that are a few months to a few years old, like you.com and Perplexity, have kind of turned even the search space upside down. And if you look at their monthly growth, it's actually alarming, right? To the point that these companies actually recognize them, and we'll see where that ends up. But I'm sure there's many factors that they're doing right, but one has just been the amount of novelty, useful novelty that these small startups are able to introduce with the right user interfaces to these people, without needing a large initial data set that has been built over decades. This acceleration that's happened that's been enabled has completely changed the field. And search is one example, right? I think we see it all over the place. So it's a great time for someone new to kind of start something. And
yeah, I think especially on the user interface piece is for example, Perplexity has a really cool user interface. They auto-generate the buttons that you can click. And with bigger companies, they're actually very protective over the user interface because their distribution is 2 billion people and they don't want to change the interaction mode. So as a small company, you have way more freedom to experiment with user interfaces that big companies can't.
Great. So we've got time for a couple more questions. We've got one here, Eddie, right next to you.
Hi there. Thank you very much. Great talk. I just want to mention two things I think two gaping holes in today's conversation, right? You mentioned multimodality, fine-tuning, RAG, so on and so forth. But we've also seen that tools and sort of communities of agents actually lead to newer emergent behavior. And so my question is, actually we're building a time series search engine as a tool to give LLMs the ability to see time, understand temporal relationships. How large is the market for tooling and communities of agents, as opposed to what we see now, which is just fine-tuning and RAG? Is there any data on this at all? What interesting companies should we be looking at building in this space?
I can share, I guess, empirically what we've seen. And actually today I was talking to Willem over there. He was sharing agents in Minecraft and things like that. And I think we'll start to see people look at examples of other companies employing agents and trying to see how it worked for them. But for our specific use case, we started with a RAG app on top of our open source software's documentation. That's step one. Something that somebody couldn't previously envision that was possible now after we created this application is when people run into issues, we want something to help them debug. So when we're debugging, there's so many different origins for issues, right? It could be a Python issue, Hugging Face issue, a system issue, a resource issue, whatever it is. When the issue has to do with our open source product, Ray, we'll actually use this agent that we developed as one of the many agents that it talks to. So this previously, this concept idea was not even brainstormed a couple weeks before we actually shipped this piece. So I see these more primitive things like RAG-based or even base LLM usage spurring a lot of new ideas. And I think agents will be the future where you'll be able to use exactly the different agents together to try to do something that previously might seem impossible.
We had one more question just up the back, Eddie. And then once the revelry commences, feel free to ask any of our panelists or have conversations around the other questions as well.
Hello. I have a quick question. In terms of evolving business models, with generative AI, there's obviously foundation models, and there are a variety of content generation fields that are getting disrupted. Like if you look at the writers union, they had a strike for the last few months, I think. And things like affiliate marketing and stuff like that have been popular as well. But what are some new sort of business models that are evolving? Not pure, a little bit different from technology, but what are some new business models that you're seeing?
So one thing that I can comment on is that In the past, there were some companies that tried to build tech-enabled services. Perhaps like one of the most prominent failures was a company called Atrium that tried to build a tech-enabled law firm. Ultimately, they were unable to make the finances work. They were unable to scale even like an efficient services company. And in part because it was really difficult to fully automate many processes. I do think that as foundation models become more powerful and as we unlock some of these agentic applications, the tech-enabled services model becomes perhaps more and more viable. And so we're just starting to see companies talk about tech-enabled or LLM-enabled accounting firms, LLM-enabled trading firms, and things like that. So that's perhaps one thing that we're observing. Even if you look at Runway, they actually have a production team in-house that both produces their own content. They just released a video series earlier this week, but also helps customers some of their production needs.
Does anyone else want to? All right, well, let's continue these conversations as we drink and be merry and eat more. We were going to stop around 8:30. We're going to extend till 9 or 9:30. So please do stick around and mingle and meet each other. A few things. I think some exploratorium staff are going to move these chairs out of the way. So if you stay sitting and someone removes the chair from underneath you, that's all that's happening there. When you do leave, we have swag bags of nice stuff that we'd love you to take as well, to thank you for coming. I'd love to thank the Exploratorium for having us here tonight. This is my first time here. I'm not from San Francisco. I don't know if you can tell. But thank you to the Exploratorium for having us here. I'd also love to thank all our fantastic guests for their hard-earned wisdom and sharing it with all of us as well. And I'd like to thank all of you for joining as well. So please give yourselves and our guests and the Exploratorium a round of applause.